Hi everyone. So in the previous video we have seen fixed size array with an example. Now we will be looking for unpacked and unpacked packed array. So let's say here the syntax for unpacked arrays. Let's say here we have one consider an example and a variable will be I can declare bit logic anything and it is a 8-bit wide. Let's say here if I say that example in the sense I can give a name of the array and it is a depth I can say. So here our syntax should be like variable type and what is the size of the array. Size in the sense that wide I can say like whether it is a 8-bit or 10-bit, whatever the bit variable. So here I can give the name of the array. So here array name I can say and next the size. So what will be the my size of the array. So now let's say I will be declaring as like logic 7 down to 0 example. So what will happen is like each of the elements will be having different memory locations and our simulators will be 32-bit wide. Let's say if I want to say that our simulator, let's say here I will be adding one um, size like here how exactly it will look. So if I add one more like let me draw four things for this one. One, two, and one more thing. So here like my example like array name will be I have given like it is a 4-bit right, let's say 0 1 2 3. So and it's 32-bit wide, let's say a simulator kind of thing like I'm considering simulator memory location. So normally this will be 0 to 31. So my only 7 bits of the simulators are used here like 0 to 7. So rest other 8 to 31 will be wasted. Wasted in the sense unused. So now like this is the one drawback I can say for this unpacked array. So now like if I want to go for packed array, so see the syntax. Let's say again going with an example, logic I will be declaring and here size itself I will be giving. Like let's say here my size will be 4 and how many bit wide I can say 7 down to 0 and again example. So this is the main difference. So now like it is a continuous string like so now like this will be my 32-bit wide. So 32-bit in the sense let's say 31 and this is 0. So 0 to 7 again 0 to 7 0 to 7 again 0 to 7. So my data will be like it's a 8-bit no doubt and the location like in one shot I can consider like 4 memory like usage of the memory with respect to simulators. So for this it has an advantage over unpacked array. So now consider an example like how we can declare in the EDA playground and we can just try with what all things I can say. So let me declare on module TB and end module. So now declare an array. Like let's say I will be declaring for unpacked array. So I said key I will be declaring that variable in logic 7 down to 0 and name was taking that example and the depth of the memory will be 4 one way and now declare for packed array. So same logic I will be considering and the size of the array will be 4 and 7 down to 0 example. Example for packed array. Just give a simple name. So here note down here I'm not giving any square bracket or nothing I'm giving. So now let's say initial, begin, end, generate a random data, and I will be using this for each loop. Just copy this example and paste it in array. So for each of I, and let's say begin and end, and generate a on random number for this one. Dollar random and display. This will be unpacked array. Let's add this 0D and add this here. So this one is for packed array, sorry, unpacked array, and now I will be adding for unpacked. I just copy this variable and paste it here and paste it here. Okay, now let's say what will be the output. Just select the simulator, save it and run it. Okay, add this semicolon here to make sure that your code is syntax free. Again, dollar display. See here now we are able to see that for this first initial begin loop, like the array is unpacked. So array now the size of the array is 4, and we are able to see the generation of the data. In the same way for packed array also we are able to see. So now sometimes what will happen is like we may get confused with this whether to declare this 4 down to 0. Like let's say now what will happen if I declare this 7 down to 0 here and 4 here. Sometimes like human error may occur. Like so now your array size will be 8. 8 times this packed array will be executed. See, okay, see here the packed array will be 8 times. So just remember that the size, if I want to declare in an array, that should be instantly after our variable declaration type. Like let's say our data type will be logic. So here if I see the declaration can be anything. Like here if I add this 7, so it like let's say it has to be executed for 7 times. 1, 2, 3, 4, 5, 6, 7. So here the size will be 7, and the maximum value can take is, let's say here now for 4 it is 3 down to 0. So 3 down to 0 in the sense like 4-bit value. So the maximum value it can take is 15. So anyway we are generating this random value. So it can go to 15. So now for us like the generated random value is 13. So just to make sure that what kind of variables we are using. So either way it can be possible. So in the earlier, if I do one, so here like it will be the size of the array will be 4, and the data may take up to the 8-bit. So if I save this one, see the differences. Earlier it was taking till 13 value. Sorry, typo mistake. So earlier it was taking 13 was the maximum value. Now it may go like beyond, like here 101, 141. So like that, just make sure that the use cases. So I hope this is clear with this packed and unpacked array, and also how the data can be utilized.